Okay, I'm going to try to take you through this, check your understanding. Okay, and what it's asking us is determine whether or not the given random variable is a binomial distribution. And what we're going to do is we're going to check the binomial settings. Do we have a fixed number of trials? We'll call that n and we'll say how many we have. Is it binary, meaning mutually exclusive? What we're going to do with this is we're going to define a success, okay? Because you either have a success or a failure. Is it independent? Usually that has to deal with replacement. Is it working like that? Same probability for each trial. Do we have that? We will label the P, okay? So that's how we're going to take a look at it. Let's jump into it right here. I have it kind of set up for us. Okay, so for the first one, shuffle a deck of cards, turn over the top card, put the card back in the deck, and shuffle it again. Repeat the process 10 times. Let X be the number of aces you observe. Okay, so the N, how many times are we doing this? 10. Success, let's define a success as pulling an ace, right? Independent, we're putting the card back in the deck, so yes, it's independent. Okay, we have that replacement. The probability, well, what's the probability of pulling an ace? Well, we have a total of 52 cards in a deck, and there are 4 aces. Okay, and here's what I like to do when, and this is a little statistic notation here. We're going to say our X is a binomial distribution, and we're going to say that we have the N is 10, and the probability is 4 out of 52. Okay, a little shorthand for saying what we got. Okay, next one. Choose 5 students at random from your class. Let Y be the number of people who are over 6 feet tall. Okay, well, we got 5 people. A success would be over 6 feet. Independent. Is it independent? If I pick one person and then the next person and then the next person, that's not independent. There's no replacement. So, no, it's not. Well, X because of not replacement. Okay. Probability, well, we don't know. Okay. You'd have to count the number of people over 6 foot tall. We don't have a probability there, so we don't know that one. So we're going to say not binomial. All right. Okay, Pedro drives the same route to work on Monday through Friday. His route includes 1 traffic light. Lucky guy. According to local traffic department, there is a 55% chance the light will be red on a random selected workday. Suppose we choose 10 of Pedro's workdays at random and let Y, the number of random times, be the red light. Okay. We've got a fixed amount. Yes. Success. We're given the probability that it is red, so we'll call red the success. We could call it green and just change our numbers, but that's fine. Is it independent? Meaning one day, does that influence the next day? Yes, it is independent, so we're good to go. So one day doesn't influence the next day. The probability they gave it to us is 0.55. Okay, so we're going to say, yes, they gave us Y as the variable. I don't usually like that, but whatever. Y is binomial, and our N is 10, and our probability is 0.55. And there we go. Okay, last thing here. Find the probability that the light is red on exactly 7 days. Okay, so what we do, go into your calculator, go to math, go to probability, and then you'll get this, the N choose X or N choose R or something like that. Anyway, you can fill this in. Okay, hit that. You get the 10 choose 7. Okay, we've got the probability is 0.55. The K is 7. 1 minus the probability, so that's going to be 0.45. And the N minus K up there is going to be 3. So crunch those numbers and put it down. All right, thank you. Have a good weekend.